All right, folks, so we are starting in the blue packet, and just to review some of the things that you will need for the review today, which I will pass out while you guys are taking the homework quiz. Exponential functions have horizontal asymptotes, and we graph them by trying to get the power to be equal to those easy power values of -1, 0, and 1. We use our transformations to figure out the location of the asymptote, and then the domain is all real numbers, and the range is dependent on where the asymptote is relative to the graph. For log functions, we have to put the log in exponential form first, which can involve some isolating of the log, so we may take a look at number 4 a little bit later. Once we put it in exponential form, then our goal is to get that exponent, which is usually going to have something to do with our y, to be equal to the power values. Remember, log functions have the tree vertical asymptotes and the range of all real numbers, and then the domain is x greater than in the direction the graph goes from the asymptote. So that's our little bit about graphing. We're going to keep the log ones fairly basic for the review and the test. Expanding and condensing, just make sure when you expand everything on the land, and when you condense, all of your coefficients go back up to the cloud. So you cannot condense coefficients. You have to put those back up as exponents first. We're going to go ahead and go down to the solving stuff because I do think those are some of the more challenging parts of the test. So let's go ahead and take a look at number 28. How do I know this is an exponential equation? Variables in the exponent. So our strategy for solving exponential equations is we want to try to get the same what? Basis. Can we do it? Yeah, where's my little square sheet? So 25 I can write as 5 squared. 125 we can write as 5 cubed. Raised to the x plus 4. Raised to the x plus 2. And then I need to make sure that I distribute to both parts of the binomial. So I'm going to have to distribute that 2 to the x and the 2 to the 4th, 3 to the x and the 3 to the 4th. That's going to be the number one mistake that you guys make on these exponential ones is forgetting to distribute to both. So 2x plus 8 and then equals 5 to the 3x plus 6. Once I have that simplified, what do I do with those bases? You're not wrong. What do we do with the 5s? Goodbye. So then 2x plus 8 equals 3x plus 6. And now we have a happy little algebra 1 equation. We want to get our x stuff on the same side. I'm going to subtract 2x, which gives me x. We're going to subtract 6, and that gives me 2. And x equals 2 is my answer. Do I have to check for extraneous solutions? No, because there's no log. However, if I am super anxious and want to do really well on this test, should I plug in my answer to check?
Probably.
Yes, sir. So we are going to plug in 2 for the x. Older calculators, make sure you are putting parentheses around those binomial powers. So newer calculators, you can just straight up plug that in. 125 to the 2 plus 2. And check it out. We get the same wild answer. So 2 sides are equal, so that shows that we have done everything accurately. Oh, when did you sneak in?
Me?
Yeah, you.
I've been here the whole time. I've been here the whole time. You missed me.
Where are you coming from?
I had to go get some food.
Everybody gets one. All right, folks, so moving on to number 29. We've got exponents and variables in the exponents. So this is an exponential equation. Folks, can I get the same basis here?
Yes.
Yeah. So whenever you have a fraction, you hone in on the denominator first. Can I write 27 as a smaller base?
Yeah.
Yeah, it's not in this column, but it is in that column. I can write 27 as 3 cubed. So if 3 to the 3rd is 27, 3 to what power gives me 1 over 27? 3 to the negative 3rd. So then I can replace that with 3 to the negative 3rd. We're not going to complete that problem. I just wanted to go over. That's how you handle those fractions. Now we've got number 30. Can I write 4 and 12 as the same base?
No.
Nope. I can write 4 as base 2, but 12 I cannot. So what do I do when I can't get the same base? You log both sides. Common log time. So common log here. Common log here. And that allows us to move our exponent out in front as a coefficient. So 3x log 4 equals log 12. So what would I do to isolate x? Divide by log 4. Can I divide 12 by 4 and get log 3? No, do not try to do any simplifying with those logs. We have to type it in the calculator exactly like that. What would be our final step in isolating x? Dividing by 3. So then x equals, I'm going to do this in 2 steps on my calculator. I'm going to do common log 12, close off the parenthesis, divided by common log 4, close off that parenthesis, boom, and then hit the division symbol 3, and that's how we take the answer divided by 3. Rounding to the thousandths place, that's 3 places past the decimal, 0.59. 7, so the 4 is not enough to bump us up, so 0.597. And again, folks, you can check yourself on these as well. If I do 4 to the 3 times that stored value, we see that, yeah, wow, it gets me 12. So don't forget that you can plug back in to check your answers. Let's go ahead and turn the page. Can I write 6 and 18 as the same base? So 18 is 6 times 3, but 6 to the first is 1, 6 to the second is 36. There's no way I can write it as base 6, as 6 raised to some power. So I would need to log both sides on that one. I think we're good. We're not going to go any further with that one. 32, what's my plan of attack? What do I do when I have one log? Put it in exponential form. Big, animal, ears. And that's going to give us 5 to the third equals x. And bam-a-lam, I don't really have to do much because 5 to the third is 125. But what do I need to do before I put a box around it? Check it. The answer part of the log, which is x in this case, has to be greater than 0. Is 125 greater than 0? Sure is. Answer checks out. What about on number 33? I have 2 logs on different sides. What do I do when they're on different sides? You cancel out the corresponding parts. So log base 4 over meow, log base 4 over meow. Cross those off. And I want you to see if you can solve it from here. Solve it and check it. Set them equal to 0. We get a quadratic. Move everybody over to the left side. Keep that x squared term positive. Factor. And we get x equals 5 and x equals negative 2. Now, when we plug back in, 5 squared is 25. Minus 2 times 5 is 10. 25 minus 10 is 15. Is 15 greater than 0? Yeah. We plug it in over here. 5 plus 10 is 15. Is 15 greater than 0? Yeah. Now for the negative 2. Folks, what's negative 2 squared? 4. If you use your calculator, you have to trap it in parentheses. Otherwise, it's going to tell you it's negative 4. So negative 2 squared is 4. And then negative 2 times negative 2 is 4. 4 plus 4 is 8. Is 8 greater than 0? Yeah. And then negative 2 plus 10 is 8 greater than 0 once more? Yes. Negative 2 is a solution. It's not about your solution being greater than 0. It's about the answer part of the log being greater than 0. So negative 2 and 5 are both solutions. A little bit strange? A little bit strange. Folks, looking at 34, we have one log. What's our plan of attack? Exponential form. So one log, big, animal, ears. We get 4 squared equals 5x plus 1. Sometimes students get weird with this one and they're like, well, we've got an exponent and we need to get like the same bases and all that stuff. Why don't we need to do that? Where's the variable? On the ground. It's not up in the exponent. Folks, this is just an Algebra 1 equation. Make sure you don't get goofy with that 4 squared. It is not 8. It is 16. So 16, 5x plus 1. Subtract the 1. Divide by 5. And x is 3. Don't forget to check. 5 times 3 is 15. Plus 1 is 16. 16 is greater than 0. Boom. X equals 3 is our solution. Number 35. Put a star by this one, because I'm going to show you a critical error that sometimes happens with this. I have 2 logs, but they are not on the same side. Can I just cross off those logs with each other? Unfortunately, no. When the 2 logs are on the same side, we condense them. Now, I'm going to intentionally make a mistake, because I see this happen on the test. We're going to multiply, so x squared minus 9x equals 2. If you're like, I see no problem, Mrs. Cairo, don't continue writing. I'm going to show you what happens if we continue in this way. So don't write this. Minus 9x minus 2. Quadratic. Product of negative 2, sum of negative 9. Can we do it? What did Mrs. Cairo promise you guys a couple of days ago? You don't have to use the quadratic formula anywhere on the homework, anywhere on the review, anywhere on the test. So if you encounter this, your first reaction should be, uh-oh, I goofed somewhere. And I think someone said what the goof was. Who caught it?
Log 6.
You gotta have that log 6. If you're like, what's the big deal? That log 6 affects how the rest of the problem goes, because I can't set that stuff equal to 2 because I don't have a log to cross off on the right side. Now that this is a 1 log equation, what do? Big animal ears. So now that 6 gets in on the mix. 6 squared equals x squared minus 9x. 36 equals x squared minus 9x. 0 equals x squared minus 9x minus 36. Product of negative 36, sum of negative 9, that would be x minus 12, and x plus 3. So then x equals positive 12, and x equals negative 3. Do both of those work? 12 is greater than 0. 12 minus 9 is 3. That's greater than 0. 12 is good. Ooh, but negative 3 in that first log is not greater than 0. So only one solution there. This is going to be kind of like the last test with the radicals, where you can get double penalized on these problems. So if you factor incorrectly and you get a negative answer that wouldn't work when you plug it back in, you have to check for those extraneous solutions, no question. So anytime you have a log, got to check for extraneous solutions. Folks, I want you to try number 36 on your own. This equation has 3 logs. What are we going to do with the 2 that are on the same side? Put them together. We're going to condense them, but they're separated by subtraction. So what operation do we use to condense? Division. So Log base 5, I'm putting the log there. 18 on the top, 3x on the bottom equals a log base 5 of 2. I got 2 logs on the opposite sides. Corresponding parts cross off. Make me proud, ladies and gentlemen. What are you going to do next? Times it by 3x. We hate fractions. Get rid of it. Multiply through by that LCD, which that's the only fraction, so just multiply by 3x on both sides. Goodbye. 18 equals 6x. Divide by 6, and x equals 3. Does it work? 3 answer parts to check. 18 is greater than 0. 3 times 3 is 9. That's greater than 0. 2 is greater than 0. Boom. X equals 3. We are in business. So, folks, that's kind of a quick run through of our plan of attack of exponentials, getting the same base or logging both sides, and how to solve logs with either putting it in exponential form, crossing off corresponding parts, or condensing first and always checking for extraneous solutions. So, folks, I'm going to pass out the 8-3 homework quiz. And then we will start going over the review once everybody gets done.